So problems 25, 26, and 27 on the review. Starting with 25, $600 was deposited in a savings account, yielding 3% annual interest compounded monthly. So that means we follow this equation. On number 27, when you see compounded continuously, then you want the formula P e to the RT. So this one's automatically for compounded continuously. This one is compounded for something else. So write an equation that represents the value of the account each year. Following that formula, P is the principal. That was $600. And then 1 plus the rate. Move this over twice. So 1, 2. So 0.03, not 0.003. 0.03 divided by 12. And then N is 12 times T, which is time. So in what year will the value of the account reach 2,000? So we need to extend our paper out just a little bit. There we go. So we set this equal to 2,000. So we have 2,000 equals 600 times 1 plus 0.03 divided by 12 is right here, is 0.0025. So 1 plus 0.0025 to the 12t. Divide both sides by 600. So divide by 10, and then divide the remaining fraction by 2. So that's 10 over 3 equals, and then 1 plus 0.025 is 1.0025 to the 12t. At this point, we apply log to both sides. So I have log of 10 to the over 3, like so, and then log of this stuff right here. At this point, we apply the power exponent, power property. 12t comes out front, so I have log of 10 over 3 equals 12t times log of 1.0025. To get t by itself, divide both sides by both 12 and log of 1.0025. So I'm dividing by 12 and dividing by log of 1.0025. So t is equal to this part right here, and I just need to punch that into my calculator. So we have log of 10 divided by 3. Don't forget to close the parentheses. And then divided by both of these, so I need to put parentheses. The best way to think about it is parentheses around your fraction bar. Either parentheses around the stuff at top or parentheses around the stuff at the bottom. So divided by, and then open parentheses, and now I can do 12 times the log of this. 12 times log of 1.0025. This parentheses closes the log. The next parentheses is the red parentheses here. On the yellow calculators, the TI-84s, you don't have to close the parentheses. And you hit enter, and we get 40.182. So the time is equal to 40.18 years. However, if we want to actually answer the question correctly, in what year? If this was 2012, and we add 40 years to that, actually 40.18, we come out with the year 2052, and then a couple months in or so. So that's the actual answer to the question. So this problem here, bought a house for $450,000, 30-year loan for 4.25%. So we have 450,000. E, the rate is 0.0425, and that's 30 years. So times 30. So when we do that on our calculator, 450,000 times e to the x, 0.0425 times 30. If you look carefully, the way this is written, this 30 is still up in the exponents, so it is 30 times 0.0425. If you were to use one of these calculators, you have to be careful to get that 30 in the exponent. So if you did it this way, 40123 times e to the x, it does give you the open parentheses. If that wasn't there, you have to be careful to make sure you use the open parentheses to get the 30 as part of the exponent. Oops, that didn't work. I gotta make sure I punch in the decimal, 0.0425 times 30. Punch in the rate rather than the number of years. Then we hit equal, we get this answer here, we hit equal here, we get the same answer there. Sorry for that minor mistake. So that is $1,610,415 and some change. Looks like about 64 cents. So that's how much she pays over the price, over the whole loan. However, we want to know what her monthly payments were. So we'll divide this amount. That was 30 years, and there's 12 years in each month. So right here, we can just hit divided. It takes the answer, divided by open parentheses, 12 times 30. And we get $4,473.38. That would be her monthly payment.